KELLER was founded in 1974 by Hannes W. Keller, the inventor of the integrated silicon measuring cell. The company's headquarters are in Winterthur in the German-speaking part of Switzerland. The company has been developing and manufacturing piezo-resistive pressure sensors here for 40 years. KELLER's core expertise lies in manufacturing isolated pressure measuring cells, which are also known as pressure transducers. Each year, the company manufactures over 1 million pressure transducers, which are often used in measuring and control technology worldwide. Pressure measuring cells allow pressure to be measured or monitored in the most confined of spaces. They are fitted in consumer and industrial products and usually run hidden in the background. Pressure transmitters are another key product sector for KELLER. These transmit electronically compensated standard measurement signals. In other words, a pressure transmitter is an enhanced type of pressure transducer, which allows the user to carry out highly precise measurements with little technical outlay. Digital manometers are also part of KELLER's product range. These devices measure the pressure of a medium and display the result on a screen. KELLER offers different types of manometers depending on the intended use and level of accuracy required. Pressure sensors are made up of many individual parts. The entire value-added chain, from the manufacture of the individual parts and the soldering of the electronics, right up to the final inspection of the finished products, takes place at the headquarters in Winterthur. All KELLER products are therefore 100% made in Switzerland. The sensor elements, which essentially consist of doped silicon, are very similar to the modern computer chips that are used in laptops or tablets today. This similarity is what gives piezo-resistive pressure measuring technology a real edge over other technologies. Since the computer industry requires these elements in very large quantities, the cost per sensor element is lower than is the case with other technologies, thanks to mass production. The piezo-resistive measuring principle exploits the change in the sensor element's electrical properties when it deforms. The force exerted on the sensor element as pressure is applied causes it to deform, and in doing so changes its electrical properties. The electrical signals, which change together with the pressure, are transmitted outward through ultra-thin bonding wires. This allows the change in the electrical signals to be measured. In the first production stage, the transducer's sensitivity, essentially the pressure range that it will measure, is defined. This is done by drilling a hole on the back of the silicon chip. More or less silicon is drilled out depending on the desired pressure range of the sensor. The sensor's reference point is now fixed by attaching a glass disc to the back of the silicon. Before doing this, the two discs are cleaned carefully and thoroughly. This is vital to ensure successful bonding of the glass and silicon later on. Next, the two discs are bonded together under vacuum using electricity and heat. This technique is commonly known as Mallory bonding. With absolute pressure sensors, the vacuum is maintained in the cavity after bonding. This allows the sensors to measure barometric pressure, for instance. In differential pressure sensors, on the other hand, a hole is made in the glass for ventilation purposes. These sensors measure the pressure relative to their environment. In the next stage of production, after the sensor element's pressure range and reference point have been defined, the wafer is machine cut into individual pressure sensors. Each sensing element is fixed onto base plates, known as glass feed-throughs, for further processing. This is often done by bonding the sensor element to the glass feed-through. The adhesives used remain a well-kept trade secret. The sensor element is now electrically bonded to the base plate. To do this, the signals from the sensor element must be connected to the glass feed-through individually, which typically requires 4 to 5 bonding connections. The delicate bonding wires, which have a diameter of just 30,000th of a millimeter, are bonded using special bonding machines that use ultrasound to weld the ultra-thin wires to the glass feed-through. Alongside automated bonding machines that process the sensor elements in high quantities, semi-automatic machines are also available for manual processing. Special customer requests, such as specific materials, can also be flexibly produced in low volumes at Keller in very small runs. As many pressure transducers are exposed to aggressive liquids or gases during their use, the sensitive sensor element is protected from harmful environmental influences by a stainless steel casing. These are generally referred to as insulated pressure measuring cells. A robot grips the sensor element and tests its electrical properties while it's being inserted into the casing. The inside of the pressure transducer, which at this point is still full of air, is now filled with oil. To prevent any measurement errors occurring as a result of air bubbles in the oil, for example, the pressure transducers are filled with oil using a special technique that lasts around 12 hours. Filling with oil means that pressure is now transferred directly from the steel membrane to the sensing element. Once all the oil has been added, the glass feed-through is electronically welded to the metal casing. The sensor is now well protected and ready for use. Manufacturing a single pressure transducer requires up to 7 welding operations. The finished pressure transducers are then washed and evaluated. Despite being industrially manufactured, sensor elements are just as unique in their behavior as humans. It's therefore necessary to examine each individual pressure transducer in testing stations and to determine its particular behavior. To do this, each unit is inserted into the measuring device by hand and exposed to different temperatures and pressures in climatic chambers until there are at least 300 measurement readings available for each sensor. The characteristics determined from this process, as well as any additional information regarding the manufacture and compensation, are enclosed with the product in the form of a calibration certificate. More than 1 million insulated pressure measuring cells are delivered and installed every year and carry out their work day by day, hidden discreetly within devices. In addition to producing pressure transducers, Keller also manufactures pressure transmitters for the automotive industry, where sensors are used to measure the contents of the fuel tank in natural gas vehicles. Pressure transducers serve as the base material for the production of pressure transmitters. Their electrical measurement signal is configured to different standard signals according to specific customer requirements, enabling a whole host of different devices to be controlled. For compensation, the pressure transducers are connected to an electronic circuit, a printed circuit board, during production. The connections are soldered by hand. The electronics and compensation are configured by machine as well as in other ways. The pressure sensors are inserted into the measuring station on pressure bars and are subjected to different levels of pressure. Meanwhile, a control computer compares the value measured with the pressure applied and varies the properties of the electronic circuit using a laser beam until the two values are identical. The sensor is now compensated and is sealed and inspected before being dispatched. The final production stage consists in labeling the pressure sensor. the finished pressure transmitter is assigned its type designation. The 22M series has been specially developed for use in so-called dual-fuel vehicles, which are fitted with engines suitable for combined natural gas and gasoline operation. The pressure transmitter measures the pressure in the fuel tank and displays how much fuel remains. Every day, almost 500,000 vehicles fitted with these types of pressure transmitters take to Europe's roads.